Full screen. Zoop. So, yeah, I'm not Simon. My name is Francois. Simon couldn't make it this week. I will show you a quick demo of PingIntelligence. If you were at yesterday's keynote at the end of the day, that's the product that I was talking about. So I'm going to demo that. But I'm also going to demo Ping data governance. And if you were in the last track in this room, you might have seen Remy Lyle's presentation about applying Marie Kondo's principle to API authorization, which was super cool. And what she didn't mention in her talk was that she was actually referring to another new product from Ping Identity called Ping Data Governance. So yeah, those are two products that are recently new with Ping Identity that are looking specifically at API security. Is this yours? So the demo use case is this. I've got a healthcare portal application. There's a Fire API. Whoa. Let's slow down a bit here. Yeah. So why can't I? Let me just back up just a tiny bit here. And I do have a few extra minutes, so I'm good. So yes, the demo use case, it's a healthcare portal application. I call it an API in the background. I've actually recorded demo in a video because I'm not, the demo gods and I are not on really good terms. So I built in my sandbox this microservice that implements the Fire API. So let's take a look at what happens when you first attach PingIntelligence for APIs to that microservice using that API and the public repo that I was talking about yesterday. So this is what it looks like after a few hours. Like you'll see PingIntelligence is showing you things that it discovered about your APIs by looking at your API metadata. So this is an overall dashboard that shows you the traffic for all your different APIs, and it shows you the username. So if you were at my keynote yesterday, you might have seen that part of the demo. So we will actually enrich the metadata with username information. So after a few hours, we can see that this user called that one API over time. So there's no attacks yet, but you can see the different URLs that have been called. You can see the tokens that have been used by that user, the IP addresses, the methods. If there's device information coming through from the user agents, we'll show that information to you. Hopefully this is visible. I know this projector is not great, so maybe you can see better on these displays there. So I'm going to now zoom in on one particular API. That's the microservice that I was talking about earlier. So similar stuff. Now we're looking at information specific to an API, and that includes the different URLs on the right that we are seeing going by looking at your API traffic metadata. So let's look at a scenario. The first scenario is a system malfunction. Some of my customers refer to this as friendly fire. Friendly fire meaning that it's kind of an attack, but it's not intentional, right? So in this case, I've got on the left side, I've got a processor. So this is the API client, and it's going through a revision. It's going through version 4 now, and that upgrade is introducing a bug. What actually happens is that for a subset of the records, this client has a null value as part of the URI, and this has never been seen before. And because this is actually removed from the actual API, it's hard to troubleshoot. It's hard to identify this problem. And so the idea is that you do go through an upgrade. This is twice removed from the API. So I'm going to actually simulate this. So here's Postman. Here's what it looks like when I call this API with a regular URI. You can see it's very responsive. Everything works well. But now if I change this value to null, you'll see now the actual API endpoint is having a really hard time. And after a while, you can see that something happened in the background. It took a very long time. There's been a number of retries. And eventually, this is going to lead to a service exhaustion. And you will have a really hard time troubleshooting something like that. So I can actually simulate this happening in a production system in my sandbox by using a collection runner in Postman. So I'm going to send a whole bunch of requests using that pattern that causes the bug. And after a little while, you will see on my I've got a special Slack channel here that is used by PingIntelligence to push notifications when an anomaly is being detected. So you can see that new notification coming, and you can see at the bottom here, we will show you which token was blocked as part of that prediction by the AI engine, and we'll also show you the user information that we dereference from the token. So I can actually see now, as an operator of this API, that the culprit, I can see that this is coming from process v4.fire.pingeng.com. So that is the first hint that I'm getting from my system to help me troubleshoot and resolve the issue. So I can just actually copy that token, and I'll show you later how we can get forensics. So I stop the simulation, and I can see that after a few requests, because my PingIntelligence is set up in blocking mode, what actually happened is that these calls are starting to get blocked by PingIntelligence for API to prevent that resource exhaustion from my API. So if I get back to the dashboard now, I can see that this is actually, that anomaly is being registered. And I can actually go I can see that it registers an attack for that API. And if I click on my blacklist, I can actually see that this is the token that has been blocked by PingIntelligence for APIs. So same thing, if I zoom in on that API, I will see on the right side all the URLs, and this is another hint that I have. Like, this is a weird URL with a /null at the end, which is providing further information for me to troubleshoot the issue that I'm running into. So my second scenario is not friendly fire. This is an intentional attack. The idea is that, you know, as a hacker, I can see this API under the hood in my browser tool, and I can actually go and use that API that's otherwise hidden and enumerate through the different URIs using the same pattern that Isabel was talking in the previous track here. You know, there's a bug in my API, and it's not doing all the authorization that it should be doing. So there's a potential data leak happening here. So again, I'm going to simulate that in Postman. So as a hacker, I can see the API is in this weird state right now where there's a lot of sensitive information that is otherwise invisible in the application. And as a hacker, I see that if I change the URI here, I can get other people's information about their healthcare information. So this is very sensitive data. So once again, I'm going to simulate this attack in Postman. I'm sending 900 requests with some time between each request in order to fly under the radar of a rate limit. And so I accelerated this a little bit, and you can see that after a few calls, PingIntelligence again predicted that this was something that was used outside of a legitimate application. I get again a notification on my Slack channel as an API provider. And instead of showing you the dashboard now, I'm going to show you the forensics that we're getting here. So I copied the header, the token that was blocked, and I can go and make an API call to PingIntelligence for API to get the forensics from there. So this is very important, you know, because a lot of security tooling is going to give you the ability to detect and block attacks, but you need to. It's not sufficient to block and detect an attack. You need to be able to, as an API provider, repair the damage that was done after an attack has been detected, right? A lot of attacks are not detected in real time. So you're good if you can detect it after maybe a couple of dozen calls, right? So you've limited the damage, but there's still some damage, and you need to repair that. Because of some regulations, you might need to go and notify a very specific subset of your users in your data, in your user base, and tell them that maybe they changed their password, or we're really sorry, but you know, we've leaked some information about you. So forensics is a very important part of PingIntelligence for APIs. So now let's add Ping Data Governance to this API. So we're attaching another sidecar to this API using Ping Data Governance. And the use case now is a dynamic user consent enforcement at the API level. And this is the kind of stuff that Remy was talking about earlier today. So user consents are very dynamic, right? Open banking is a good example of that, right? So as a user, I may say that an application is allowed to do this on my behalf, but is not allowed to see that information, right? So what I want to do now, am I playing? Yes. I want to, just following the same pattern that Remy was talking about, I want on behalf of my API, take into consideration that user consent information that I'm going to be retrieving, and I want to affect the API response going back through a system. So this is what Ping Data Governance UI looks like. And this is the a set of user preferences that I'm retrieving through another API call. So this could be, if you're using, oh my God, 3 minutes. All right, let's get going. So I've got 3 fields here: address, history, and telecom, and what it is. So, and I was talking about caching earlier. So right now I'm doing it real time. There's no caching, but there was a question about performance earlier, so I could adjust that caching. So in Ping Data Governance here, I'm going to look at these properties. So if history is false, I'm going to apply an exclude attribute to my payload. And this is the JSON path that I'm going to filter out. And so on the left side, I've got Postman. I'm calling my API. This is what my API call looks like. Same API as before. So as a user now, I changed those preferences. I don't want to allow any of these 3 details here. And you can see on the left side, if I make another API call, this information is gone, and that is happening in real time. So now I'm adding address, address comes back. Notice how the token is not refreshing here. This is the same token, and the user preferences are changing. So we're not looking at the OAuth scope here to change what the API call is returning. We're looking at real live user consent outside of the scope associated to this API. So, in summary, and I think, am I still good on time here? Okay, so PingIntelligence for API and Ping Data Governance. So I showed you PingIntelligence for APIs, doing classification between good and bad traffic, doing API cybersecurity, and giving you insights about your APIs. And I showed you Ping Data Governance, helping you with consent management, and specifically with the runtime enforcement of these consent in order to do fine-grained authorization. Thank you very much.